Friends, in this video we are going to learn how to draw the circuit diagram to study the input-output characteristic for transistor in the common emitter configuration. Friends, this is one of the questions that is often asked in your board examination, ISC board examination, from the chapters of semiconductors devices. Now friends, in this circuit diagram we will be using an NPN transistor, and in order to draw the symbol of an NPN transistor, what we are going to do, we will be taking the we will be drawing a circle, and along with the vertical line, this vertical line representing the base of the transistor, then two slant line, one with an arrow, another without an arrow. The line with an arrow is representing the emitter and the line without the arrow represents the collector. Friends, now friends, in order to aid to your memory, how would you remember it is an NPN transistor or a PNP transistor if the arrow is not pointing in? So you can see the arrow is not pointing in. So if the arrow is not pointing in, then such transistor is an NPN transistor. So that's how you should remember. If the arrow is pointing in, then it is a PNP transistor. So here I've drawn an NPN transistor. Now since we have been asked to draw the circuit diagram for a transistor in a common emitter mode, so what I'm going to do, I'm going to make this emitter common to both the ends, that means to the input end and to the output end. Remember friends, the end, the left end is often referred as input end. So this is the end from where you are going to provide the input audio signal, and this is the end, right side end is often used to provide the output or to take the output. So that's the right end is going to be called as output end. Now since transistor being a three-terminal device, I need one end to be made common to both input as an and to output, and in this case I'm going to use the emitter, which I'm going to make it common to both. So that's why you can see I've joined this. So these two ends are going to be the ends across which we are going to supply the input, and these two ends are there where we are going to where I'm going to take the output. That's why it becomes a common emitter configuration. Now friends, now once I have drawn all these things, I've drawn the basic structure. So once we have drawn the transistor in common emitter configuration, the next thing is that we need to bias our transistor. Now what we mean by biasing? Biasing of a transistor simply means connecting it to some external DC power supply. Now connecting to some external DC power supply, and there are two types of biasing. One is the forward biasing, another one is the reverse biasing. So in order to bias a transistor, what I need to do, I need to bias the EB junction in the forward bias mode and the CB junction in the reverse bias mode. So what I need to do, I need to bias the EB junction. So this is my EB junction. We need to bias it in the forward bias mode, whereas the CB junction must be biased in the reverse bias mode. So whenever you do this, our transistor becomes or is said to be biased in the normal active mode of biasing. So friend, this is the most used mode for biasing a transistor, and this biasing is used for using the transistor as an amplifier also, and in order to study the characteristic curve of for the transistor. So friends, this is after this, what now we need to do, we will bias this transistor and then we will move on to the next part of the circuit. Now in order to do the biasing, as I told you, EB junction has to be forward biased. So what we are going to do, we will be connecting at EB junction with the in the forward mode. So this is my EB junction. So what I am going to do, this being N, this being P, and this again being N. So EB being in the forward mode, so P of this base P must be connected with the positive of the battery. So here you can see I've drawn the positive of the battery, and CB junction reverse bias mode, and the collector of this transistor happens to be N. So what I'm going to do, I am going to connect the collector to the positive of battery so that it becomes a reverse bias, N connected with the positive of a DC power supply will make it to be a reverse biased mode. So this is how I'm going to connect the battery. So what I have done, I have drawn the batteries over there. Now I need to connect them, but I won't be connecting them directly. I won't be connecting it like this and like this and like this and like this, because since I'm looking forward to draw, or in order to study the characteristic curves, I need to vary the voltage, input voltage and output voltage, input current and output current. So I need to vary them. So in order to have that variation, I need a potential divider circuit. I need to vary the voltage. So what I'm going to do, I'm going to connect it these two batteries with the help of a resistance to the circuit. Okay, so the base biasing battery is written as VBB and the collector biasing battery is written as VCC. And then what I'm doing, I am connecting it through a resistance. So you can see I'm drawing a resistance over there, and then and similarly I'm going to draw the resistance in towards the output side also. So this is a resistance in the output circuit, and this is the resistance in the input circuit. Now friends, what I need to do, I need to connect them. So what I'm going to do, I'm going to extend this wire. I'm going to extend this wire to connect it over here, and then I'm going to extend this wire and connect to the, so this is how I'm going to connect both the circuits. So this input is connected here, this output is connected. Now friends, I need to connect the topmost. So what I need to do, I need to extend it this, but this I'm not going to connect it to the battery. I'm going to connect it through the resistor. So here I'm taking a jockey and connecting it to the base battery, and similarly I'm going to take the jockey and connect it to the collector battery. Once I have done this, the basic biasing of the transistor has been done, friends. Once the biasing is done, I now need to connect the ammeter and the voltmeter so that I can record the input current and voltage as well as the output current and voltage. So what I'm going to do, I'm now going to connect an ammeter. So this is a micro ammeter which is connected towards the base so as to record the input current IB, and then I'm going to connect ammeter on the output circuit which is going to record the output current IC. So this is the output current, friends. Now I need to connect a battery also. I need to connect a voltmeter so that it can record the voltage. So here I am connecting the voltmeter in the output circuit, and this is going to be VCE, which is going to record the output voltage, and here I am going to connect the input voltage, a voltmeter which is going to record the input voltage VBE. Once this has been done, this makes now our circuit is complete, which will be used to study the input output characteristic, friends. Now remember, when you have drawn this circuit, the places which are of utmost importance and the teachers are going to check you for those. The first thing that you should know, you should be able to draw, the first thing that is very important, you should be able to draw the correct symbol. So the symbol for transistor. So this should be very correctly drawn. You should be able to draw the symbol for transistor. In this case we are talking about an NPN transistor. So you should be able to draw the symbol for transistor. The second important thing that you should be able to do is to bias the transistor correctly. The biasing of the transistor. Now when I say biasing of the transistor, friends, as I told you, biasing means normal active mode of biasing, that is the EB junction, forward biased, whereas CB junction being reverse bias. So this is the second place where you will be checked for your work. Third thing for which you will be checked is applying the ammeter and the voltmeter correctly. So you should be able to apply the ammeter and voltmeter correctly. So ammeter must be correctly connected in the input and at the output. So you should be able to show clearly the input and output, ammeter and voltmeter. And the next important thing that you will be marked for is IC, IB and IE. So your diagram should clearly show IC, IB and IE, friends. So this is the IE, this was the IB, and this is here is the IC. So all these things, if you remember it, you will be able to get 3 marks in this particular question. Generally this question will be for 2 to 3 marks, friends.